All right, number one, you have Can I bring markers here?
So what's today's agenda? It's class.
Going over the text.
And then Friday. So you might give it back.
You want it back? No, I ain't take it. I gave it back.
What?
So what you had was epsilon is equal to v square over 2 minus mu over r, right? And you're given h is equal to RT VP or RA VA. Okay. So what this means is, see, first of all, if you're considering an orbit, this is RT, right? And this, at this point, for an elliptical orbit, at the apoapsis and at the periapsis, only at these points, the velocity vector is perpendicular to the position vector. So if you see, typically what is H? H is RT, RV, cosine of angle between them. But over here, sorry, sine of angle between them. So it's R cross V, right? You following? At this point, if this is perpendicular, so what happens is your H is simply R cross V, the angle is sine 90, it's 1. If you substitute, from this you can say V square or VA square is equal to H over H square over R square. You see it? Or you can use this, or VP equal to H square over RT square. Why don't I do HA and HP? Why is it not HA and HP?
Because momentum is constant.
It's constant, exactly. Because it is conserved, it doesn't matter. HA and HP are the same. At any point, HA and HP are the same. And that is what you were required to prove for problem number 3. You're required to prove what was one. It was just a simple statement. Prove that two-body motion is confined to a plane. What is H direction?
Perpendicular to
Huh?
perpendicular to R.
What is H direction, Philip?
Is it like angular is on the order?
See, it is this direction.
Yeah.
I've told you many times. This defines the direction. This itself, this vector defines the direction of this movement.
So it's basically cross product.
It cannot, this direction cannot be defined by this arrow itself. If you have something like this, right? If this is H coming out. This hand defines the direction. Right? So right-handed rule, this hand defines the direction of H. So what it means is, if this changes, what happens? If H changes, what happens? The plane itself will change. Okay? If H changes in direction, this plane itself will change. The orbit will change. And what happens if this H becomes bigger? If the magnitude changes,
Then the orbit becomes,
the orbit becomes bigger.
you missed the square.
Huh?
The dp squared.
So this age, this is your this thing for the third one. It's the third one, I think, right? So you start with r cross. You start with this r double dot. Let's do this first. So you have epsilon is equal to h square over, let's do r p square divided by 2 minus mu over rp. If I use v square over a square over rp here, this automatically becomes rp. Okay? Now if you simplify this, what was rp given to be? Did I give you a rp value?
A square root of 1 minus.
Huh?
Should be A times square root of 1 minus E.
No, a into 1 minus e, right? A into 1 minus e and 1. I gave you
That was in the second problem.
exactly. So why would you say it is not given?
Yeah. 3 of the problems were like linked together.
That is what thinking is about. I shouldn't give you in this problem and give the same information in the next problem. If you see through the paper, you should be able to figure out what RP, what RA to use. Right? So if you use RP, what was RP given to be? A into 1 minus E, right? And RA is A into 1 plus E. So if you just substitute this, you have h square divided by a square into 1 minus e square over 2 minus mu over a into 1 minus e. Okay? You do this, you have a square over a square into 1 minus e square. What is h? Value of h? H was also given to you on the other problem. H is, I gave you a actually. Root of a mu 1 minus e square. This is given to you.
They will derive from that problem.
If you just move around, and if you look at problem number 2, a is given to be h square over mu 1 minus e square. So if you move around, you're going to get this. And the way you have to figure out is, if you know what the end result of this is, you will try to substitute everything in that end result form. If you do that, so what you're going to get is h square is a mu 1 minus e square divided by 2 1 minus e whole square minus mu over a into 1 minus. Okay, so this can be written as, we have a here, right? Okay, a square. So this square, this cancels. So just think about mu 1 minus e 1 plus e divided by 1 minus e square 2a. So this cancels with this minus mu over a into 1 minus. If I just take minus mu over 2a outside, this would be mu. Let's do this. Just take minus mu over 2a.
You got to square the AU 1 minus E squared.
Huh?
You got to square the AU 1 minus E squared at the top.
Which one? This one?
No, at the top.
This?
All the way at the top. Yeah, that one at E squared. It's A squared over RP squared.
It's h square over 2a square. H is that.
Okay,
H square
I see
will
what
be
you did.
I have mu plus mu e, okay, minus mu divided by a into 1 minus e.
Did you ever study the function?
No, that's what he's saying. He's saying all the formulas is in the on the text. So that's it.
Alright, what are you going to get here is this is I have a squared this is 1 minus e. This is we're going to get is mu over 2a minus mu plus where did an extra mu come?
Two. So that will increase minus two. That will be minus two. E minus two.
1 minus e divided by
Yeah.
2a.
Oh, okay. I missed that part. I think I did up to.
Yes.
Sorry.
Okay. So if you do this, you're going to get this. You can do the same thing for 1 plus a is, if you substitute Ra equal to a into 1 plus e, you're going to end up with the same result. So what this means is energy of an object of an orbit is purely a function of its semi-major axis or size. This is the size. A defines the size. E defines the shape. The second one was very simple actually. So you're given what are you trying to prove? You're given this, right? A equal to Ra plus Rp over 2. Okay. So what is the orbit equation for Ra? What is the orbit equation for Ra?
X square.
What is the orbit equation itself?
X square over mu.
H square over mu into 1 over 1 plus e cosine theta. That theta changes. That's it. What is theta for Ra?
For RA is 0. For oh sorry, RA is 180, RP.
Ra is 180, right? So you have H square over mu 1 over 1 minus e. Okay. And then what you have is plus H square over mu 1 over 1 plus e divided by 2. To simplify this, you'll end up with an expression for A. So what you're going to end up is A square over mu into 1 plus E plus 1 minus E divided by 1 minus E square. A square over 2 mu. Okay. This cancels, this cancels, this is simply equal to E square over.
I think you made a mistake.
No, I'm right.
No, in the middle section. You see how there's 1 over 1 minus e squared?
Huh?
You see how you have 1 minus e squared, and then
This one?
on the next level, the next equation above.
Second step.
The second step,
Hmm.
yes. You have 1 minus e squared.
Oh, that's what one.
That is 1 minus E
Oh,
square.
yeah.
And then where did it go on the next step?
Oh, no.
1 minus E square can be written as 1 plus E, 1 minus E.
A square minus B square form.
A square minus B square form.
Oh, I see.
1 is square, right? 1 square is the 1 is 1 square.
Okay.
So you can write A square minus B square is A minus B into A plus B. That's how it's written.
Yeah, that was my fault. I didn't see that.
So this is how we get it. See this how simple it is. Right?
It's
So what do you need? If you just use this result in RA is what? A square over mu, okay? 1 over 1 minus E, correct? Now look into this. A square, this is what? A square divided by mu into 1 over 1 minus E, again 1 plus E. You agree? This is H square mu. 1 minus E square is 1 minus E, 1 plus E. What is this?
That's RA.
That's RA. Right? Or what you can do is H square over mu, this is also equal to, so you move this on the other side. This is also equal to A into 1 plus E. Right? Look into this. A is equal to A square divided by mu 1 over 1 minus E into 1 plus E. Okay? A into 1 plus E is equal to H square mu 1 minus E. What is this term? That's RA. You see it? How simple it is? So this itself is RA. RA is equal to A into 1 plus E. Similarly, you can do it for RP. Now, how do you prove that E is equal to RA minus RP? You have to at least attempt in parts. If you know RA, RP, A into 1 minus E, and RA is A into 1 plus E, you can at least do this, right? RA minus RP divided by RA plus RP. What is this? A into 1 minus C minus, sorry, 1 plus C A into 1 minus C divided by A 1 plus C plus A 1 minus C. So here what happens is you get 2AE in the numerator. In the denominator you are going to get your AE cancels, you get 2A. Cancel, just E is left. Right? You see, A minus A cancels out. AE minus of minus AE is 2AE. Then you have A plus A is 2A. AE minus AE cancels out. You get 2A, A2AE over 2A. 2A, 2A cancels, E is left. This is what you are required to prove. The third one is simply conservation of angular momentum. We have done this, you guys have done this quite a number of times. I thought you guys had practiced this. Q R is equal to 0. So what do? You cross with R, that's it.
What is the question?
The question really asks you for show and justify that two-body motion is confined to plane fixed in space. So what did we say? If this is the angular momentum, right? If the motion has to be fixed in this plane, this should not change. The magnitude or direction of this should not change. And this is the angular momentum. The derivative should be 0. It should not change means the derivative of this h should be 0. Right? You recall what it is?
What's your question?
You recall what I'm saying? You don't recall what I'm saying? Constants of motion. Angular momentum is conserved, linear momentum is conserved, total mechanical energy is conserved. You have proved all these conservation. This is just a 2-line answer. You just cross, take this, which is third one. Have R cross with R plus mu over R cube. R cross with R is equal to 0. So what happens? This goes to 0. Why? Vector cross with itself. This can be written as d over, so if dt of R cross with R dot is equal to 0. R cross with R dot is simply H. So d over dt of H is 0. See, 2 lines. You understand? It's actually very simple.
Dr. Sunday, I misread that, going back to problem 1, I misread that to 2U, right?
This one?
Yeah, that part.
So what happens is the common this is the denominator is 2a to 1 minus c, right?
Yeah.
For this, 2 is missing.
Oh, so you just,
It's like taking 2.
yeah, 2, and, okay, I see it.
You see that? So this is a 2-line problem, that's it. The fourth one is a piece of cake actually. Fourth one, you're given, see you actually have all the formulas here. What are you given? A and E, right? What do you want? You want RA. What do you want? Find the perigee and apogee altitudes. The only confusing thing should have been altitudes. What is perigee and apogee altitude? RP, what is RP? A into 1 minus E. You have this formula all along. You just have to substitute A and E. That's it.
Don't you have to add the radius of like
You subtract the radius. So once you get RP, RP is not the, it's the perigee radius. So that's the reason I gave you the radius of the earth. I asked you for altitude, right? If I had given you altitude, then you add it. If I ask you altitude, it means I'm asking you the height. This gives you the radius. This is the perigee radius from the center of the earth, right? What does this give you? RT will always give you from the center. What you're being asked is, what is this? This. So it is simply RP. So this is, let's say, AP, or yeah, AP would be altitude at perigee is equal to RP minus RE. RE is this. Similarly, RA is also A. RA is just A into 1 plus E. And the second part is simply, again, very simple. If you knew this mu, I wrote mu on the board. It's just minus mu over 2A. That's it. A was given, right? A is 9144 kilometers. Caleb, any doubts?
you just explain like the whole how is it minus
So when I give you the altitude, what does altitude mean? Altitude means something from the surface of Earth. Right? If this is your orbiting body, when we consider orbit, there is no up or down. From the surface going up is altitude. What do you understand by altitude?
the surface going up to a point
For example, even aircraft, what does altitude mean?
where above the ground.
Above the sea level, right? So this all should be sea level, right? You see that? This RT is always called the perigee radius or periapsis radius. RA is apogee radius or apoapsis radius. So this radius is always from the center of the earth. From the center, for example, you have to dig down. If you want to really calculate, if you want to really measure this is not RP, okay? This is what? This is RP. This is RE, the radius of the earth. Yes, ma'am.
Are you Dr. Asante? Okay. What time will you be back in your office?
In a few minutes.
In a few minutes?
In around 3:15.
Pardon?
3:15.
Okay. Thank you.
All right. So this, now you understand why negative. Why do you take? I asked you for this.
Okay, that's what I need to know. Is what you asked.
This is what I asked you. Altitude of perigee altitude. So apogee altitude would be. So this is all on the surface. It's like you're standing here and looking up. Because of gravity, or because of the huge surface, we feel it's flat. But it's all. So this is Is it clear now? So the next one this is part A, part 1. Part 2 is very simple, right? So it says you are asked for the energy of the orbit. You just have to use minus mu over 2A. A was given to you. Mu, I gave it on the board. It was not given on the other side.
Yeah, still I found H with that formula and then substituted that. So I think that should be right, but it came into negative. Oh, okay.
It should be negative.
It was negative? Okay.
So that's what, you are focused on answers. Don't focus on answers. What does, if I ask you for this, right, RP and RA, that means it is what kind of an orbit? Elliptical orbit. Is it a circular orbit?
I mean, it might be if they both are equal.
Whenever if we talk about closed orbits, energy is always what?
Conserve.
Huh?
Conserve. Energy is conserved.
It's zero.
Oh, energy is less than zero.
Energy is less than 0, is negative. What is between 0 and 1?
Zero.
I think that's correct.
Oh, that's an ellipse.
Forever.
That's
Zero.
That's eccentricity.
Eccentricity of the
Eccentricity is between 0 and 1.
ellipse.
Okay? So that means that energy is negative. Negative means, what does that energy negative mean? It cannot escape. Right? As long as the energy is negative, it will not escape. If the energy is 0, what happens?
it stays like those.
It's just enough to escape. But it will not it will not go anything beyond escape. It will just escape and be in a
Oblivion.
what orbit?
Oblivion.
Huh?
Just probably in the sun orbit.
What orbit will it be in if it escapes?
The body's orbit,
It won't be in any orbit.
It will be in a parabolic orbit.
Oh, that's true.
Oh, yeah, I remember.
Energy, we say energy equal to 0 for parabolic orbit, right? When you figure out the V escapes,
Yeah, I remember that.
so V escape equal to 0. When we are finding V escape, we correlate it to parabolic orbit and then say energy is 0. Energy is 0 means it is just enough to escape, but it will not do anything beyond escape. The relative motion will cease. It's not moving any closer, but at the same time it is not going any farther. It's a lost in space problem. And what happens if energy is greater than 0? It will hyperbolic orbit. It will go into it will escape and keep going since it has more energy. Now the last one, the fifth one.
This the one we had to plot, right? This the one we had to plot.
The fifth one, yeah, you have to plot. The fifth one is actually very, very simple. What I wanted you to realize is, so what was given to you? The formula was given to you, right? Did you recognize that formula? What was the formula?
Oh, we had to plot and then graph it.
R is equal to
Yeah.
P over 1 plus E cosine theta. So compare this to this. A square over mu divided by 1 plus E cosine theta. This h square over mu is itself a constant, right? For a given orbit. H is constant, mu is constant. So can I replace that by P? It's just another constant. Right? When I gave you this P value, so what I wanted you guys to do was just do this. Theta and corresponding R. Okay? So what was the first P? P equal to 2 and E equal to 0. Right? So here it will be P over 1. Okay? So regardless of what theta is, 0, 90, 180, 270, 360. P is always what? 2, 2, 2, 2, 2.
So we had a rating that was the same.
Right. So what we are doing is, so this is 90 degrees, right? 90 degrees, sorry, 0 degrees is in this direction. 2, 2, 2, 2, 2. This is a circle. What this means is for a circular orbit, this is constant, right? I was telling you that R is always just a function of theta. That is what this shows. R is a function of theta, but for a circular orbit, it doesn't matter. It's always the same. The value of R itself is the same, but the direction matters. The direction when theta is equal to 0, it's here. When theta is equal to 90, it's here. When theta is equal to 180, it's here. When theta 270, it's here. And I do the same thing for What was the other one?
I know E was like 0.7.
P equal to 6 divided by 1 plus 0.6 cosine theta. Okay. So what you see here is, what does this 0.6 mean?
That's the
E is between 0 and 1. So what kind of a ellipse, right? So what you do is you substitute 0. If you substitute 0, it will be 6 over 1.6. That will be the least value. Okay? That will be the highest. See, what is the highest value of cosine theta? 1. It is 1. It has to be 0, minus 1 to 1. Highest value is 1. What is the least value? Minus 1. When it is 1, this value will be smallest because the denominator is the highest. Right? It will be here, somewhere here. You can calculate the actual value. At 90 degrees, it will be what? 6. Correct? Cosine 90 is 0. It will be 6 over 1. So it will be, this will be much less than 6. This will be slightly more than 6. At 180, what is the value?
Again, the same.
6 over 0.4. Right? So it is 60 over 4, which is
60 over 4, you said?
10.5,
15.
15, 15. So this will be 15. 270, it will be again 0, 6. This and this distance will be the same. At 360 again it will be here. Now if you look at, if you join this, you'll end up with an ellipse. So this is not like a, it will not be an X shape, it will be an actual ellipse. Okay?
But that will not be the P, right?
Huh?
That distance is not the P.
This is not the P.
This is not the P.
P is actually something called parameter. You can look it up for a. This is actually a very precise, this is the equation of a conic section. This is exactly the equation of a conic section. Conic sections are nothing but, you just section a cone, you'll get circle, ellipse, parabola, and hyperbola. Alright, so this is it. Do you think it is approachable? Huh? You cannot have the same thing again. That is what I don't want you guys to do. It is not about, see,
That's what I need.
alright. So the discussion of today's class was, look, your growth happens only, growth will not happen in your comfort zone. Growth will always happen outside of your comfort zone. If you think growth and just experience is not growth, you have to get uncomfortable to grow, whether in career or in life. If you think your grade is determining your understanding or your education in this program, then this was your exam. It was actually very simple. Any instructor can do this to you. Throw you off guard. Most of you. I'm not saying everyone. I'm sure many would have attempted. But it was good enough to throw you off guard. Right?
Yeah.
So what you should try to do is think about it. Always think. This is simple actually if you think. If you learn to think, if you actually practice to think, you practice to solve the problem, solve the examination. Practice to think. And your grade will not be determined, this will not affect your grade negatively. But I want you to, for the rest of the semester, I want you to demonstrate that you can think. This assignment requires there is a extra credit work in this assignment. 4.5, which is orbital elements. I want you to implement MATLAB program for that. That is what I asked you to do previously, but I don't think any of you did that. I want you to implement the algorithm. Everything should be done by MATLAB. So you have to implement if loops, for loops. You should not determine. If I give you the R and V, if I input R and V in geocentric equatorial orbit, the program should give me orbital elements.
I'm sorry, I'm not understanding what the assignment is. And
Did you look at the assignment? The fifth assignment?
the only homework that I've seen was the one with the drawing on there.
It's like a, when you go on Blackboard, it's like a sentence before you click the link of all the problems. It's like 7 words, 8 problems. That are from the book.
And also, see, the one more thing I want to mention here is I'm trying to prepare you for next semester. I intend to offer satellite design, and I honestly want everyone to participate in that elective. It will not be anywhere close to this course. We'll only use part of this course. It will be a design-based course where you'll design a satellite, a CubeSat. You may have to do a lot of reading, some CAD designs, but it will be much more fun. I won't be. See, this has to be difficult. This has to be made difficult. Why? Because it's one of your core courses for aerospace engineers. This is a core course, right? This is the, frankly speaking or really speaking, this is the only space course you do. Everything else is almost aero. You do some propulsion, but not space propulsion. You do propulsion, right? You focus on aircraft propulsion. You don't use turbines in aircraft. Right? You cannot use turbines. Why can't you use turbines?
There's no air to suck in. That's the
There's
first
no
part.
atmosphere to suck in. It has to be a chemical, impulse kind of a thruster. You know what an impulse thruster is?
Yeah.
It's like your any kind of, you do your Coke model experiment, you put a Mentos or that kind of thruster works in space. Turbines don't work, and you don't learn that kind of thruster, right? You learn impulse thrusters. That's not part of your propulsion.
We're in propulsion now. We're in propulsion.
So do you learn any kind of thrusters, space thrusters? You do very specifically you do aircraft propulsion. So this is the only course which is really space related. Okay. How many of you all intend to take satellite design? Don't be scared. It will really be. It will not be anywhere like anything like this.
Okay, when you say satellite design, right, I guess I don't know what I can do with that. I don't know what I can do with satellite design.
What do you do with capstone design, senior design?
We're doing.
What do you do with senior design?
I'm doing design with a fly.
We're building.
So what do you do?
We're building a community.
Exactly, you do a satellite, you build a satellite.
Yeah.
You
So
think
that
about
can be like substituted as a senior design course?
no.
Yeah,
I think it was my
If I come to your office, can you write my ticket?
Tomorrow.
You have it tomorrow?
Yeah.
Okay, can I forward you the email where I did my MATLAB?
Okay, sure.
You got your email on here?
Yeah.
So if I email it now, you can look at it, see, make sure I did it right.
I'll look at it, not right away.
Okay. Well, I'm gonna send it to you now then. I took a screenshot.